Continental Jigsaw Puzzle. I know it's fun to play with a jigsaw puzzle, enhancing the complexity of our minds. But if you've already seen a world map multiple times or even once, and stared at it for a minute, you can probably say that we live in a giant jigsaw puzzle. This is the world map. By observing it, one land masses seems to fit well together if you have a chance to connect it. Well, South America and Africa fits well as India and Antarctica, and Madagascar and Western Africa, and many more. If we can have a chance to connect all of them, it will form a large landmass that contains all of the present islands and continents. Evidence 2. The distribution of fossils. Fossils are preserved remains or traces of organisms from the past. As an example, the fossil of fern Glossopteris were found in 250 million years old rocks in southern India, Antarctica, southern Africa, Australia, and South America, locations which are so far and somehow unrelated from each other in the present day, but a single species of plant grew and prospered 250 million years ago. But how is that possible? Well, if we go back to the jigsaw puzzle that we saw earlier and mark all the locations that the fossils of Glossopteris were found, we can observe that they can be connected, which at some point proves that they are once connected. And it's not only the Glossopteris, but also the fossils of ancient animals such as Cynognathus, Listosaurus, and Mesosaurus grew and prospered in locations 200 million years ago, which are far and somehow unrelated in the present day. Well, you might say that maybe they just swim across the continents, but no, as a matter of fact, the mentioned animals are poor and weak swimmers.
When the magma comes out of the mid-Atlantic ridge and cools down, creating new volcanic rocks, the magnetite, a magnetic mineral inside the magma, makes the molten magma to align themselves towards the North Pole. In this picture, the North Pole will be somewhere here. The hardened rocks are just like the compass needles, always pointing towards the North Magnetic Pole. Depending on the place the rock hardens, the rocks will point the North Pole in different angles. Scientists can predict where the rock was formed by looking at the angle towards the North Pole if they know where the North Pole is. Moreover, scientists made an interesting observation from the rock that was found near mid-Atlantic ridge where new volcanic rocks were kept on forming. The interesting observation was that the same piece of rock showed different alignments or angles towards the North Pole in different layers.
The idea of seafloor spreading is supported by the following evidence. First is the age of rocks. Scientists find out that youngest rocks are found near the ridge, while oldest rocks found far from the ridge. Ibig sabihin, kung andito yung ridge, yung mga nasa malapit sa kanya ay younger. Ibig sabihin, ito yung mga bagong crust. At yung malayo, yung mga crust na malayo sa ating ridge, ayun naman daw yung mga older crust. Sila yung nasa subduction zone na. So, nakita dito yung pagkakaiba-iba ng age ng rocks. So, paano to naging ebidensya na ginamit ng seafloor spreading? Dahil daw, sa pag-move ng magma papunta sa mid-ocean ridge, nakakapag-create ito ng bagong crust.
Evidence 5. Coal deposits. This somehow connected the ancient climates. Coal deposits, which are basically the corpse of plants and animals that died a million of years ago, were found in temperate and polar regions in the present day. However, coal is only found when formed in tropical regions, so we can somehow hypothesize that those present cold regions of the Earth are actually tropical regions millions of years ago, which agrees to the jigsaw puzzle or the Pangea map that we saw earlier.